Welcome everyone. This is the first trial of screen recording and lecturing. Today we'll discuss the concept of homology and and how it is better and worse than fundamental groups. Fundamental groups to study topological spaces. So for a view, the fundamental group was basically the group of all loops for a topological space, like for example maybe like a torus, which has a property that we had to first choose a base point on the space. Let's say this is our base point, and then we draw around this topological space a loop which is closed around this point, and then that loop should not be continuously deformable into another loop. So a fundamental group was basically a collection of equivalence classes of loops such that the equivalence was defined by continuous deformation into one another, which in language of topology is called a homotopy equivalence or homotopic loops. So for example, for a torus, if you remember, was the fundamental group was Z, direct sum Z was the pi one of the torus, because if you see, we choose this point and then we make a loop, kind of like a loop around the surface, and close it around here. We see, since torus is a two-dimensional manifold, we cannot further contract it, so it kind of circles around this base, the base of the torus, and closes itself on the point. That was the one circle. And another loop that we could have drawn was like, starting from here, we go around the central hole and we close it over here. So one of these loop was represented by this one, this, and one of the loop was represented by this. And this was, well, so because of the fundamental group of circle, because as we know that torus is nothing but the cross product of two circles, and we knew that the fundamental group of the circle was nothing but integers, because you can just take a circle and maybe you can choose this base point and then go around the circle once and then around another, and just basically keep going on as much as you want. So it's like one whole turn. So you could have created kind of like a bijection between Z to the S1 through n mapping to to e power 2 pi in. So that's what the fundamental group of the circle was this, and we knew that from our knowledge of one common theorem that pi 1 of the product space S1 cross S1 is nothing but pi 1 of S1 cross with the pi 1 of course S1. So this was all fun and good with fundamental groups, but there was some major problems with the fundamental groups. For example, well, for most of the topological spaces, the fundamental groups were not abelian, and as we know from our experience of group theory, non-abelian groups are generally very complicated and hard to deal with, and also kind of very unintuitive sometimes. So that was actually one of the main concerns of fundamental group theory, or higher homotopic group theory. So that's why we came, the mathematician, especially through the intelligence of Emmy Noether, that we came upon the homology theory, which is kind of like an abelian alternative to fundamental groups. But of course, since we are removing a complexity of fundamental groups, we are definitely losing some information. So homology group not necessarily provides as much insight into the topological space as fundamental or higher homotopic groups reveal.